So yesterday we looked at solving simultaneous equations graphically. Today we're going to move to an algebraic method. Don't forget though, as we do this, what we're doing is these are still straight lines on a graph. Okay? This is a straight line on a graph, this is a straight line on a graph. Even though we don't look at the graph and we're solving them algebraically, we are still finding the point where this line crosses this line. Okay, if the two lines are parallel, they won't cross, there will not be a solution. You'll get a nonsense answer if that was the case. If the lines were just two different forms of the same line, you'd also get a nonsense solution because there'll be infinite solutions. Okay, so just be aware everything we did yesterday applies to what we're doing today, and you could go back and do yesterday's exercise, or some of it this way, solving them algebraically. There's another method we're going to look at down the track. Okay, so today we are solving the simultaneous equations by substitution. Okay, so we are substituting something into something else, and you can see the two equations. This is y equals mx plus c, this is ax plus by equals something. Okay, so they're straight line graphs, they're both straight line graphs. Okay, we could plot this using the gradient intercept method, we could plot this using the this is the gradient intercept method, this is using the, we could plot this one using the x and y intercepts. Okay, but they'd still be straight lines on a graph. Now what we can see is this is y equals, so y is equal to 2x minus 1, or y is 2x minus 1. So what we're going to do is we're going to take that 2x minus 1 and we're going to put it there instead of that y. So we're going to get 3x plus 4, and instead of writing y, we're going to write 2x minus 1 equals 29. Okay, now the reason we have to do that, and the reason why we need two equations to solve these, we can't solve for just one variable. When we got two variables, we need more than one equation. We need the two equations if we've got the two variables, the x and the y. So what we're doing here is we're saying y is 2x minus 1. So instead of y in this equation, we're putting in, instead of 4 times y, we're putting 4 times 2x minus 1. Now we only have x's in the equation. There is only one variable, and that's x. It's there twice, but there's only one variable, which is x. Okay, so just that is the key step here. Instead of y, we're putting the 2x minus 1 because we know that y is equal to 2x minus 1. So we're not changing the equation because it's equal. So here, now we just expand it. We've got 3x plus 4 times 2x is 8x, plus 4 times negative 1 is minus 4 equals 29. 11x minus 4 equals 29. And a plus 4 there and plus 4 there. I get 11x equals 33. So x equals 3. So that's what x is, but we need to find x and y. So we go back to this first equation and we write y equals 2 times 3 minus 1. Just putting the x in instead of the 3 in instead of the x, because now we know that x equals 3. 2 times 3 is 6 minus 1 is 5. So our solution to that equation is 3, 5. And if we check it, 3 times 3 is 9. 4 times 5 is 20, 9 plus 20 is 29. We know it's correct. Okay, so that's it, an algebraic solution of simultaneous equations. So let's just have a look. Now this one, both the equations are in y equals mx plus c mode. So what we're going to do is exactly the same as we did the first time. That's what y is that. So instead of y in this equation, I'm just going to put 5x minus 8. So here I'm going to go, instead of y, I'm going to put 5x minus 8 equals, so that's instead of the y, I've put 5x minus 8. So on this side we've got the minus 3x plus 16 again. And we got an equation with unknowns on both sides. There's just x's in it. We have to get rid of one of the x's. So here I'm going to get rid of the minus 3x because I don't like minuses. It doesn't matter. You could get rid of the 5x if you want, but I'm going to get rid of the minus 3x by going the opposite is plus 3x. And I have to do the same to the other side. So I end up with 8x minus 8 equals 16. And plus the 8, same to the other side, 8x equals 24. Then I divide by 8 to cancel them out, same to the other side, and I get x equals 3. So now I can go back over here and I can write y equals 5 times 3 minus 8, because now we know x is 3, so I'm putting 3 in there. 15 minus 8 is 7, so a solution to this equation is 3, 7. X is 3, y is 7. So we put 3 in here, we get 5 times 3 is 15 minus 8 is 7. If we put it in here, we get negative 3 times 3 is negative 3 times 3 is negative 9. Negative 9 plus 16, or 16 minus 9, is 7. So we know it's the right answer. That's it. That's all we're doing today. Just substitution. Okay, there are some examples in the book if you want to have a look. We're doing today exercise 4.3. Remember, we're making the tick sheet up as we go along, so make sure you write down these questions from exercise 4.3. And have a go at them. See how you go. If you've got any questions, just make sure you're asked. I will say one thing. Here we've got y equals 2x minus 1. If we had x equals something, we would substitute it in here for this x value. Okay? So it could go either way. So exercise 4.3, I'll leave you to work on that and I'll catch up with you next time.